right, ladies and gents, chapter 4. We're going to get into parabolas, ellipses, hyperbolas. They're called conics. But chapter 4, sections 1 and 2 deals with rationals. You guys have algebraically dealt with rationals. What's a rational expression? It's a fraction. It's a grown-up fraction, okay? What is in the denominator of a rational? An x, a variable, okay? So when you think of a rational expression, there's going to be some values that make your denominator 0. So what we're going to do today is we are going to find what's called asymptotes, vertical, horizontal, and slant, okay? When you guys take your quiz, not your test on Wednesday, but when you take your quiz, we're going to put in a quiz somewhere on there. I'll put it up on the board. But we're going to put in a quiz for 4.1 and 4.2. It's just going to be calculator stuff. In pre-cal, we graph this by hand. In here, you guys are going to use your graphing calculators. So I'll teach you how to do it, that sort of a thing. But this is what the graph of a rational function looks like. Sometimes we call them like boomerangs, something like that. But what would happen, guys? What's the only number that I can't use for the parent function? 1 over x.
0.
Can't use 0. Why? What happens?
Because then it becomes like an imaginary.
Becomes undefined, okay? So 0 would be your vertical and horizontal asymptote. What that means is your graph is going to get really, 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 really close to 0, but not touch it. It doesn't include those values. So what we're going to do today is algebraically find the vertical asymptote, the horizontal asymptote, and the slant asymptote. We're not graphing today. We're going to do that after your test, which will be on your calculator. But here are the ways to find. Okay, this is super simple. I suggest this section right here, you guys take a screenshot of and put on every single slide because we're going to keep referring to the same thing. But let's talk about what these are and then we're going to do examples. A vertical asymptote, how do you find it? What does it say to do in your little set of notes here? Set the denominator equal to 0. Guys, the side conversations need to stop. All right, vertical asymptote, you set the denominator equal to 0. It is that simple. What does it say right here about your vertical asymptote? Your graph cannot cross it. At some points, there's some graphs, for whatever reason, very, outlandish, outlier kinds of things. It'll cross a horizontal once in a while. It'll cross a slant once in a while. But never, ever, ever will your graph cross a vertical asymptote because that's where the denominator becomes undefined. Horizontal asymptote, how do we find this? And once we do an example, this will be really easy. But you compare the degrees of the numerator and the denominator. What is the degree? The highest exponent, okay? So you look at the highest exponent of the numerator. You look at it of the denominator and you compare it. If the numerator degree is less than the denominator, your horizontal asymptote is always at y equals 0. If they are the same, it's always the leading coefficient of the numerator over the leading coefficient of the denominator. And if the degree of the numerator is greater, there's no horizontal asymptote. So I want you guys to notice something. If there's no horizontal asymptote, then you do have a slant. That's the only time you have a slant asymptote is if you don't have a horizontal. You'll never have both. And again, once we do some of these examples, you're going to be like, oh, this is easy. So in a case of you having a slant asymptote, that's when the degree of the numerator is greater than the denominator. How do we find it? What does it say to do? Divide. You're going to use long division. You're going to use long division. And what does it say right here about the remainder? Ignore the remainder. Your answer for your slant asymptote is in y equals mx plus b form. It does not include the remainder. Once we do a few examples, you guys are going to be like, this is so easy, I promise. All right, last thing I want to discuss before we do examples is something called a hole. All right, a hole exists. This is what a hole looks like on a graph. Say you have your rational function goes like this, and then all of a sudden there's a hole right here, and then your function continues. What does an open dot represent? That's not a part of the graph. A hole is one point, like literally one little point on part of your graph that for whatever reason, that specific value would make your fraction undefined, so it doesn't exist there. So algebraically, the way that you figure this out, this is how I like to say it. You're going to factor the numerator and the denominator. I'm going to show you, I'm going to write this out, I'm going to show you an example, and then we're going to go. You guys are going to be good. Once you factor, you're going to cross out parentheses that are the same. And set that equal to 0. That's going to give you the x value of your whole. That's going to give you the x part of your whole. Then you take the x part, you plug x into the simplified rational. To find y. Now that's very wordy. I understand that. As soon as I do one example here, you're going to be like, oh, that's easy.
Wouldn't that say like the same something?
Cross out parentheses that are the same and set that equal to 0. Okay, so let's pretend, hold on, let me think for a second. X squared plus 5x plus 4 over, guys, x plus 1, okay? Here's our rational, right? So this is how we're going to attack these problems. If you are trying to find a whole, we always factor first. So what am I going to factor the numerator into? X plus 1 and x plus what? Okay. My denominator is x plus 1. Okay, let's identify if there's any wholes. What I wrote down. Factor numerator and denominator, then cross out the parentheses that are the same. What's the same? And you do what with those? You set it equal to 0. So what is the x part of my whole? -1. Okay, the x part of my whole is at -1, comma. What do I do with that x value? I plug it in to the simplified version. What is -1 plus 4? 3. There's your whole. It's literally that easy. And we're going to do it time and time again. Every single time we do these problems, the first thing you do is factor to find the whole. And then we're going to find vertical asymptote, horizontal asymptote, slant asymptote. And you guys are going to be just fine. If I were you, I would take that horizontal asymptote little blurb of notes about the numerator and denominator degree, take a little picture of it, and put it on every slide so you can just refer to it. I'm going to keep asking the same questions over and over again, so you keep repeating it in your mind because that's how you remember it. So let's go. The first thing we do, number 1, is you factor. Is there anything to factor? No. So everybody with me, how do you find the vertical asymptote? Set what? Say it out loud. Denominator equal to 0. So my vertical asymptote is at x equals perfect. Vertical asymptote, yep. Okay, my horizontal asymptote, my ha. What do? What does the rule say? Compare. Guys, look at the rules, come on. What do you compare? Come on, guys. The numerator degree to the what? Denominator degree. What's the degree of the numerator? No. 0. What's the degree of the denominator? 1. 0 is what than 1? Less than. So look at that little cheat sheet of notes. When the degree of the numerator is less than the degree of the denominator, what is your horizontal asymptote? Y equals 0. If you have a horizontal asymptote, what do you know about the slant? There is none. You can't have both. So if you have a horizontal, you do not have a slant. And now let's move on. We're going to keep going. I need everybody to stay with me. First thing we do every single time is factor. Anything to factor? No. So my vertical asymptote. Everybody, how do you find the vertical asymptote? Set the denominator equal to 0. So 3x equals negative 2. What's my vertical asymptote? X equals negative 2/3. What does that mean, guys? That's a vertical line at x equals negative 2/3 that your graph is going to get really, really, really close to, but not what? Doesn't touch it. Because what happens when x is negative 2/3? Your denominator becomes what? 0. Then it's undefined. That's what your vertical asymptote is. So let's find our horizontal. We compare the numerator degree to the denominator degree. What is the degree of the numerator? 1. The exponent on x is 1. What's the degree of the denominator? 1. 1 is what to 1? Equal to. Look at your little cheat sheet. When the degrees are the same, it's the leading coefficient of the numerator, which is 2, the number in front of x, over the leading coefficient of the denominator, which is perfect. If you have a horizontal, what do you know about slant? There isn't one. None. Perfect. Yep. All right, let's go to 3. Can you factor anything? No. Can you factor x squared plus 1? No. Can you factor x squared minus 1? Yes, but that's not x squared minus 1. So let's go through. Vertical asymptote. How do you find it? You set what? Everybody set what? Denominator equal to 0. Good. X plus 2 equals 0. I want to be so annoying with, oh my gosh, she keeps asking the same thing. Good. I want this stuck in your brain. So your vertical asymptote is at x equals negative 2. That vertical boundary line that your graph gets really, really close to but doesn't do what? Doesn't touch it. Because look, guys, if you put negative 2 back in the denominator, what happens? Negative 2 plus 2 is 0. Then it becomes undefined. Perfect. All right, let's compare now. What's the degree of the numerator for my horizontal asymptote? 2. What's the degree of the denominator? 1. 2 is what than 1? Greater than. Yeah. If the numerator degree is greater than the denominator, what's your horizontal asymptote? There isn't one. So if there isn't a horizontal line that's the asymptote, then that means you're going to have a what? A slanted one. How do you find a slant asymptote? Long division. So I have x plus 2 on the outside, and then on the inside I have x squared. I have to have 0x plus 1. You got to have a placeholder for everything. So let's go back a few weeks to our long division. First term into first term. X times what gives me x squared? X. Good. Get your subtraction ready before you multiply. X times x is x squared. X times 2 is, plus 2x. And before I subtract, what do I have to do with that minus sign? So distribute. So 0 minus 2x is negative 2x. What happens to my x squareds? They cancel, and then I bring down plus 1. And we do it again. First term into first term. X times what gives me negative 2x? Negative 2. Get your subtraction ready. Negative 2 times x is negative 2x. Negative 2 and positive 2 is minus 4. And I need to do what? Distribute. Do my 2x's cancel out? Yes. So do I have to do any more? No. What's your slant asymptote is at y equals x minus 2. You don't have to worry about what? The remainder. It's always going to be in y equals mx plus b. So instead of a horizontal asymptote, you have a slanted line where it's going to cross that negative 2 and your slope is 1 over 1, and it's just a slanted dotted line that your graph's going to get. It's like a boundary line.
What's the remainder?
There is no remainder. You don't worry about the remainder.
Oh, I suppose it's -3, right?
No, it's 5 because you got to distribute the plus sign, but you don't worry about the remainder. Skip to, oh yeah, wait. All right, let's go to the next one. We don't need to do these. Let's skip to 3. We have to do what first? Got to factor first. You have to always factor first because if you don't, you'll end up with vertical asymptotes that aren't really both vertical asymptotes. You're missing a hole. So you always have to find the holes first. So let's factor the numerator. What does my numerator factor into? X. Come on, guys. X minus 1, x plus 2. Okay. And what's my denominator? x minus 3, and x plus 2. Do we have a whole? Yes. Do you have something that is exactly the same on top and bottom? So cross it out and you set it equal to 0. X plus 2 equals 0. We're finding our whole. So I have a whole at x equals negative 2, comma, what? What do I plug that back into? I plug it back into the simplified version here. So negative 2 minus 1 over negative 2 minus 3. What is negative 2 minus 1? Negative 3 over negative 2 minus 3. Negative 5. Simplify that. 3 over 5. So you have a whole at negative 2, comma 3/5. And then this is what we base everything else on. How do you find your vertical asymptote, guys? Set the denominator equal to 0. X minus 3 equals 0. So I have a vertical asymptote at x equals 3. Let's talk about our horizontal asymptote. You compare numerator degree to the denominator. It's the same if you go back to the original, if you go back to this one, but stay with the simplified. What is the simplified degree of the numerator? 1. What about the denominator? 1. 1 and 1 are what to each other? Equal to. If the degrees of the numerator and the denominator are the same, how do you find this horizontal asymptote? Leading coefficient in the numerator, what's in front of x? 1. Over what's in front of x in the denominator? Still 1. Both 1 and 1. Here, 1 and 1. So you have your horizontal asymptote at y equals 1. If you have a horizontal, what do you know about your slant? There is not one. Every single time you factor, find the whole, and then do everything based upon your simplified version. All right, same thing here. Let's factor. My a term is not 1, so I have to remember that. You either use the grouping method or my little shortcut. Doesn't matter to me. I'll do the grouping method for this one. What are the factors of 18 that multiply to give me 18 but add to give me 7? 9 and negative 2. So God bless you. 3x squared plus 9x minus 2x minus 6. If I were to group this, what comes out of the first set of parentheses? 3x. And I'm left with x plus 3. What comes out of the second? Negative 2. And I'm left with x plus 3. So when I factor this, it's x plus 3 times 3x minus 2, correct? Okay. Now factor the denominator. X plus, x plus 3, x plus 1. Okay. Do we have anything that is exactly the same in the numerator and the denominator? Yes, so what do? You cross it off and set it equal to 0. Perfect. So x plus 3 equals 0. X equals negative 3. My whole is at negative 3 comma something. What do I plug negative 3 into? Not the original, the what? The simplified version. So I have 3 times negative 3 minus 2 over negative 3 plus 1. What's negative 3 times 3? Negative 9 minus 2 is negative 11 over, what's negative 3 minus 2? Negative 2. Can I simplify that or make it a little better? Negative 3 comma 11 over 2. If you want to write 5.5, that's fine. So there's your whole.
Wait, how did we change that? Oh, no.
So now, guys, we do everything based upon this simplified. So vertical asymptote. How do we find vertical asymptote for the 900th time? Set the denominator equals 0. Good. X plus 1 equals 0. So x equals negative 1. Perfect. How do you find the horizontal asymptote? You compare the degrees. If you want to go back to the original for this, you can. You're going to get the same answer. In either the original or the simplified, the degrees of the numerator and the denominator are the same. It's either 2 and 2 or 1 and 1. So I'm going to use the simplified. The degree of the numerator is 1, degree of the denominator is 1, so they're equal to each other. How do you find when it's equal to? Leading coefficient of the numerator, which is 3, over the leading coefficient of the denominator, which is 1. Do I have to put the 1? No. If you have a horizontal, what do you know about a slant? Done. You can never have a horizontal and a slant. It won't happen. All right, just make sure you guys see that. If I don't finish, I'll finish and put the video up. But don't be fooled by this. Why would this be a little tricky? It's not in standard form. Rewrite it, guys. What does this really say? Negative 7x plus 3, negative 7x plus 3 over 2x plus 3. Okay, don't make a silly mistake because you're just not paying attention. Is there anything to factor? No. So let's go ahead and go through real quick. How do you find the vertical asymptote? You set denominator equal to 0. 2x equals negative 3. So x equals negative 3 over 2. If I were to plug negative 3 over 2 in for x, my denominator would become 0. That's that vertical line that's going to get really close to but not touch. So now let's talk about our horizontal asymptote. What is the degree of the numerator and the degree of the denominator? Both of them are 1. If they are the same, how do you find the horizontal asymptote? Leading coefficient of the numerator over leading coefficient of the denominator. If you have a horizontal, what do you know about your slant? There is none. On WebAssign, tonight they're going to ask you, or this weekend, for the horizontal and the vertical. It says enter in a comma separated list. What you have to do is say x equals negative 3 over 2, comma, y equals negative 7 over 2. Make sure your x and y are lowercase. 2 common mistakes that I get emails about. All right, this one's easy. What do we do first? Got to factor. What can I factor my numerator into? Anything? My numerator? Just x plus 3, okay? What's my denominator, Luna? X minus 3, x plus 3. We always find our wholes first. Do we have something that's exactly the same on the top and the bottom? Yes, so we cross it out, x plus 3, and we set it equal to 0. So I'm finding my whole. The x part of my whole is at what? Negative 3. And then I take my simplified version, and I plug into that. Why did I put a 1 on top? Because everything canceled out, so there's something there. You have to have a placeholder. So if I plug negative 3 in for x, guys, what's negative 3 minus 3? No. Negative 6. So my whole is at negative 1/6. If I say 1 over negative 3 minus 3, that gives me negative 1/6. So there's your whole. So now we do everything based upon our simplified. So my vertical asymptote, how do you find vertical asymptote? Denominator equal to 0, x minus 3 equals 0, so x equals 3. My horizontal asymptote, we compare the numerator to denominator. What is the degree of the numerator? 0. What's the degree of the denominator? 1. 0 is less than 1, so my horizontal asymptote is at y equals 0. If I have a horizontal, what do you know about a slant? None.
0 counts as
It's just the x-axis. Yeah. All right, 2 more. We can do this. All right, let's do the last 2. What do we do primero? Factor. What can I factor x squared minus 4 into? X plus 2, x minus 2. Perfect. What do I factor my denominator to? X minus 2 and x minus 1. Perfect. Anything in common? X minus 2. So look, my simplified version is right here. X plus 2, x minus 1. That's what we're going to base everything on. But my whole, whatever they have in common, you cross it out and set equal to 0. So my x value here is 2. So I have a whole at 2 comma. If I were to plug in 2 here, 2 plus 2 over 2 minus 1 gives me what? 4 over 1. So I have a whole at 2 comma 4. And now we do everything based upon our simplified version. So your vertical asymptote. How do I find vertical? Make the bottom 0, denominator equal to 0, so x equals 1. Perfect. Our horizontal asymptote, we compare Compare what? The degrees of the numerator and denominator. Guys, in the original, it's 2 and 2. In the simplified, it's 1 and 1. In both cases, they are what? They're equal. They're the same. So you take the leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator, which is 1. So your horizontal asymptote is at y equals 1. If you have a horizontal asymptote, what do you not have? A slant. Good. I know I'm going quickly, but this is not terribly difficult. And the more you practice this, say in your mind, how do I find the vertical? How do I find the horizontal? It becomes just second nature. So Monday and Tuesday, we can troubleshoot, we can ask questions, we can work on stuff to prepare you for your test on Wednesday. Let's do this last one. What do I have to do first? You got to factor. So my numerator, what does my numerator factor into? X plus 2 and x minus 1. Perfect. My denominator, 2 times 2 is 4. So factors of 4 that multiply to give you 4, add to give you 5. Okay, x plus 4 and x plus 1. Is that what you guys said? All right, I'm doing the shortcut. I have to divide each term by 2 because my a term is not 1, right? So I'm left with here x plus 2 and 2x plus 1. Agreed? Yes or no, guys? Okay. So with what I factored, I'm looking at, do I have a hole? Okay, where's my hole? At x plus 2? So I'm going to say, okay, my hole, set it equal to 0. X plus 2 equals 0. So I have a hole at x equals negative 2. My simplified version is x minus 1 over 2x plus 1. So I take my x value of the hole and I plug it in there. So I have negative 2 minus 1 over negative 2 times 2 plus 1. What's negative 2 minus 1? Negative 3 over what? Negative 3? Yeah. So what's negative 3 divided by negative 3? Positive 1. So I have a hole at negative 2, comma 1. And then I use my simplified version to do everything else. So let's find our vertical asymptote. Guys, how do you find a vertical asymptote? Denominator equal to 0. 2x plus 1 equals 0. 2x equals negative 1. So my vertical asymptote is at x equals negative 1/2. That means my graph's going to get really, really close to that vertical line, but never do what? Touch it. Because if I were to put negative 1/2 into my equation, my denominator would become what? My denominator would become what? 0. Good. All right, let's find our horizontal asymptote. Compare numerator degree to the denominator. What's the degree of the numerator? 1. What's the degree of the denominator? Yes. I don't know why I wrote 2. So 1 equals 1? So your horizontal asymptote is y equals the degree of the numerator, or the leading coefficient is 1 over the leading coefficient of denominator, 2. And if you guys have a horizontal, what do you know about your slant? There is none. Perfect. So your homework, guys, I know there's one for 4.2 that's due. I'm going to push all the dates out. But your homework, just do the 4.1 homework. If you have questions about it, we will go over it on Monday in class. But we're going to prepare for your test Monday and Tuesday to get ready for your test Wednesday. We good? Thank you guys so much. I know that was fast. You did great. Luna, question.